Good morning everyone. My name is AKSHAY. Today I will be presenting a seminar on chain growth and step growth polymerization. These two are the fundamental mechanisms by which polymers are formed. Understanding these mechanisms explains how materials like plastics, fibers and resins are produced. Chain growth polymerization is also known as addition polymerization. In this process, a large number of monomer molecules join through an addition reaction. No byproduct is eliminated in this type of polymerization. This reaction normally needs a catalyst or initiator such as hydrogen peroxide or benzoyl peroxide to start the chain. The monomers used here generally contain double bonds. Some common examples of chain growth polymers are polyethylene, polypropylene, polystyrene, PVC. All these materials are used in everyday applications and like packaging, bottles, pipes and household plastics. Mechanism of chain growth polymerization. Chain growth polymerization proceeds in three main steps: initiation, propagation and termination. In the initiation step, the initiator decomposes to form free radicals or ions which attack the monomer and create a reactive chain end. This creates the starting point for the chain. Propagation is the stage where the chain grows rapidly. The reactive center adds monomers one by one. As long as monomer is available, the chain continues to grow and becomes longer and longer. Termination occurs when the growing chain stops. This may happen by combination of two radical chain ends or by disproportionation where a hydrogen atom is transferred. Chain transfer is another possibility where the radical shifts to another molecule. Termination is important because it determines the molecular weight of the polymer. Disproportionation. One radical abstracts a hydrogen atom from another and chain transfer. Radical is transferred to solvent or another molecule. Types of chain growth polymerization. There are four types of chain growth polymerization: free radical polymerization, cationic polymerization, anionic polymerization, and coordination polymerization. Free radical polymerization is used for plastics like polyethylene and PVC. Cationic and anionic polymerization depend on the type of ions involved. Coordination polymerization, such as the Ziegler-Natta process, is used to make polymers like isotactic polypropylene. Examples of chain growth polymers. Examples include polyethylene, polypropylene, polystyrene, PVC, PTFE or Teflon, and PMMA. These examples highlight how chain growth polymerization is widely used in the polymer industry. Step growth polymerization. Now let us move to step growth polymerization. This type of polymerization involves monomers that have two or more functional groups. These monomers react step by step to form dimers, then trimers, then oligomers, and finally long chain polymers. Unlike chain growth polymerization, any molecule can react with any other molecule. Mechanism of step growth polymerization. Step growth polymerization starts with monomers that have functional groups such as COOH, OH, NH2 or NCO. A common example is the reaction between a diacid and a diol. These functional groups are naturally reactive, so no external initiator is required. In step growth polymerization, two functional groups react and form a new covalent bond. This step usually eliminates a small molecule such as water, HCl or methanol. This is why step growth polymerization is often called condensation polymerization. The first product formed is a dimer. The dimer still has free functional groups, so it can react again with another monomer or another dimer. This leads to the formation of trimers, pentamers, and oligomers. There is no initiator or active center like in chain growth polymerization. Any species present in the reaction mixture may react with any another. A unique feature of strip growth polymerization is that high molecular weight polymer appears only when almost all functional groups have reacted, typically around 99% conversion. In the early stages, only low molecular weight species such as dimers or trimers are present. This slideshow shows the mechanism for polyester formation, also called PET or pterylene. The monomers involved are ethylene glycol and terephthalic acid. The OH group or ethylene glycol reacts with the COH group of terephthalic acid to form ester linkages and eliminate water. This reaction continues repeatedly, forming the polymer chain. This slideshow shows the mechanism of nylon 6,6 formation. Hexamethylene diamine reacts with adipic acid. The amine group reacts with the acid group to form amide linkages with water as a byproduct. Repeated condensation reactions lead to the formation of the polyamide chain. Thank you for giving this opportunity.